I'll briefly show how to use an interactive simulation that demonstrates calculating the number of equilibrium stages using the McCabe-Thiele method. This is for a binary mixture of methanol and water. And look at the view of the simulation. You'll notice that this box is checked here so that the diagram is on the right that shows the number of stages, shows the feed rate and the quality. The feed rate's fixed at 50% methanol, 50% water, and the quality fixed at 0.5, meaning it's a 50-50 mixture of liquid and vapor. The condenser is a complete condenser. Diagram on the left shows two mass balances for above and below where the feed enters the system. And then it shows counting off stages where this is the equilibrium line, and for methanol water we fit data using a two-parameter Margulis equation, so it's a non-ideal solution. The distillate mole fraction, and the mole fractions are all for methanol, the more volatile component. Distillate mole fraction 0.94, that's set with this slider, and then the desired bottoms mole fraction set with this slider, and you can see we don't quite get to desired value. We actually, for this number of stages, we're below that. The other options in this simulation are to number the stages starting from the bottom instead of the top. Arbitrary, seems the majority of textbooks use numbering from the top. So let's look at this interactive simulation and see how things behave as we change these parameters. So here we're looking at the interactive simulation, and as I mentioned, we can change this mole fraction required in distillate. We go to higher values, we require more stages. I can display just the XY diagram, make it a little clearer, where we have equilibrium line and then two mass balances, and then the feed is here, and the feed, remember, mole fraction is fixed at 0.5. Let's go back to look at both diagrams. In addition to changing the mole fractions of the distillate here in the bottoms, I can change the external reflux ratio. And what that refers to is the liquid flow rate here entering column divided by the distillate flow rate, what we're collecting and leaving. Remember, this is a complete condenser. So as I increase this, you can see I get a lower and lower mole fraction for the bottoms, and at some point then I would require fewer stages if I have a higher reflux ratio. So the idea is that hopefully this simulation helps you understand how we step through to determine the number of stages by using mass balance on this line, here and here, and equilibrium compositions here, 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 the phases that are in equilibrium.